Why, hello everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight is one of our students who I will let introduce himself.
Hi, my name's Eli. I'm a physics student at UMB.
So, tonight we are going to be taking you on a tour of the moons of our solar system. We did a tour of the planets last month, and while they're really cool, there's also a lot of really awesome moons out there too. And so that's what we're going to be focusing on tonight. Now, as I get our tour all set up, if you do have any questions throughout the show tonight, feel free to leave them down in the comments. Eli will keep an eye on those for me and will let me know as they come up. If we don't get to them right away, we will also have time at the end to answer questions as well. All right, well, let's get started. So we are out in space, and I guess before I get too far, let me remember to say that for our tour of the moons of the solar system today, we are using a program called Celestia. It's a really awesome kind of solar system explorer. And if you're interested in trying it out for yourself, it is free to download. You can find the link in the video description. All right, so we are starting off pretty far out in space. We can see our sun there looking just like all of the other stars up in the nighttime sky. It really is no different than all those other stars, except that we're just a lot closer to it. And of course, what we love about our star is our own solar system, our home, our planets that all live around our star. Now, I've had to turn on these blue kind of guidelines to show us the orbits of the planets, because if you notice when I turn these off, you can't really tell where the planets are. Planets are really small and pretty far apart as well. And so as we kind of fly in, we start to see some of those inner planets as we get closer in. And as I said, we're not focusing on the planets themselves tonight, but instead the moons around the planets. And there are quite a lot of moons in our solar system, over 150. Some of them are small, tiny little things. Some of them are actually larger than some of the planets that we have. And there are some that are incredibly interesting, especially to astronomers. And so we're going to take a look at those. Now, if we're going to start a tour of the moons, we actually don't start with the first planet in our solar system, Mercury, or even with Venus, because neither of those planets have moons. The first planet, if we're going in order from innermost to outermost, the first planet to have a moon is our very own Earth. And of course, we have one moon that we call the moon. And you can see here that it is maybe a little bit further out than some people think. It's about 30 Earths away from the Earth, and it's quite small. So if we kind of, oops, there we go, fly on in to our moon is about a fourth of the size of the Earth, which seems small, but actually compared to the size of the Earth, our moon is quite a big moon. We'll see that most moons around the other planets are much, much, much smaller than the planet itself. So the moon being only a fourth the size of the Earth is quite a big moon. And it's always been a little bit of a mystery as to why the moon is so big comparatively. And we think that it comes down to how it formed. So the moon has an interesting past. We actually think that what happened was about 4.5 billion years ago, back when the solar system was just getting started, there was a really big object that hit the Earth. We're thinking something roughly the same size as Mars. And when it hit the Earth, it thankfully wasn't big enough to completely destroy the planet, but it was a big enough impact that a lot of material got spewed out into space. And most of that, or maybe not most, but a lot of that material then collected around the Earth and slowly collected together, gathered up into one big object, which eventually became our moon. And so we think that's why it's so large compared to the size of the Earth, because there was just a lot of material ejected out from this big impact. Is because the composition of the moon, the rocks and stuff that make it up, are very similar to the rocks that we have here on the surface of the Earth, to the Earth's crust. And that's the bulk of the material that would have been blasted off from this impact. There are other things as well, but I don't want to get too complicated with it. But as we look at our moon, we see this kind of big ball of rock. I mean, that's what it is. Some of the interesting features are these kind of darker areas, which we call the lunar maria. Maria is Latin for sea, a body of water, and that comes from a time before we had telescopes. When we looked up at the moon and the sky, we saw those dark areas and we thought that they were actually bodies of water. Now, once we had telescopes and we got better views, we realized, no, it's not water, it's just a darker colored rock. But by then the name had kind of become common, and so the name stuck, and we still call them the lunar maria. And they're darker in color because they're a different type of rock than the rest of the surface. This dark rock is actually a lava rock, like basalt. Well, not like, it is basalt, a lava rock. And so that actually tells us that the moon long ago had lava flows. And these lava flows had welled up from underneath the surface, probably in cracks from impacts from things hitting the moon, flooded the surface, and filled in a lot of those craters that were already there and kind of paved over them smooth, just like you fill in potholes in the road. And this left behind this darker, kind of smoother lunar maria that we see compared to the brighter, lighter gray terrain, which is very, very heavily cratered, where we're seeing just craters from billions and billions of years worth of impacts. In these dark patches, these maria, those craters have been filled in by these lava flows. Now, since this happened, the moon has cooled down a lot. It's no longer molten inside, and so we don't see any lava flows or anything like that present anymore. That stopped probably about 3 billion years ago, but it still leads to some very interesting features that we see on the moon. All right, I think that's enough of our moon, so let's head on to the next planet to have moons, and that is the red planet Mars. And as we can see here, Mars actually has 2 moons. They are named Phobos and Deimos, which means fear and panic. And as we zoom in to Phobos, we can see that it, well, once I get it in sunlight, Phobos, why are you? Oh, I know what's going on. It's in Mars' shadow, so we can't see any detail. Let me just speed up time here a little bit. Oops, too fast. So that we can actually see the details of this moon. There we go, that's better. So you can see that Phobos here looks quite a bit different than our moon. It's not a nice ball of rock. It's more of a lumpy chunk of rock. In fact, we lovingly call these lumpy space potatoes. And because they are so small and so irregular shaped, we think that both Phobos and Mars's other moon, Deimos, which we can also go take a look at, we think that these are both actually captured asteroids. So asteroids are pieces of rock that were left over from the formation of the planets. These are just pieces of rock that didn't end up forming planets. And most of them live in an area we call the asteroid belt, which sits between Mars and Jupiter. So it's not too surprising that Mars, being right on the edge of this zone that has lots and lots and lots of chunks of rock, a couple of these got a little bit too close to Mars, and Mars's gravity just grabbed hold of them, and they ended up going around Mars instead of staying going around the sun as asteroids, and became moons of Mars. And they do look very much like asteroids. The compositions are very much the same, and so we're fairly certain that that's what's happened here. And so Mars has two asteroid lumpy space potatoes for moons. All right. So our next planet to have moons, we're going to move out into the outer planets to Jupiter. And as we fly into Jupiter here, we can see lots of moons. I'm pretty sure we don't have every single one of them in here, but Jupiter does have a staggering grand total of 79 moons. Now, most of these are lumpy space potatoes, are asteroids that got captured by Mars's gravity. Again, not too surprising with Jupiter being on the other side of the asteroid belt, and of course being such a large planet with such strong gravity, it's very easy for it to grab hold of these things. But Jupiter does have a set of 4 larger moons that are known as the Galilean Moons. These are not lumpy space potatoes. They're much more like our moon, well, in shape and size. And they're called the Galilean Moons because it was the astronomer Galileo Galilei who discovered them. The very first time, looking through a telescope at Jupiter, he saw these 4 little points of light going around Jupiter. And that was actually a huge thing at the time. It helped to give evidence and give credence to the idea that the Earth was not the center of our solar system and that the sun was. And of these Galilean moons, they're really, really cool moons. So we're going to start with the closest of the 4. And this is the moon. I keep forgetting to click over here. There we go. This is the moon Io. So at the planetarium, we have a nickname for Io, which is also in shadow. Let's just, there we go. We like to call Io the pizza moon because, well, it kind of looks like a pizza, right? That yellow and white cheese, the red sauce. I'm not going to get into an argument again, Eli, so olives or sausages, whatever you want on your pizza for those black spots. But what's... Go ahead.
No, I was just going to say, we'll leave it be. We'll spare them.
Anyone who's been to one of these has heard us have this argument.
And I'm going to be upfront. When things were in person and I would talk about Io, I would say, if you're here with one of the other people here, you've been misinformed. It's not sausage. It's pizza, it's olives. But you've got the reins right now, so I'll let you take it.
I'm also the boss, so I think I can put my foot down and say it is sausage.
Yeah, that's true. That's true.
Anyway, that's not what makes Io so interesting. Even our little squabble is not what makes Io so interesting. So first off, Io is about the same size as our moon. And we can see colors and stuff looks very different. We don't really see craters like we see on our moon. But the other interesting thing is all of those black specks that we jokingly argue over are actually volcanoes. Io has over 150 active volcanoes. That's more than Earth. That's more than anything else in our solar system. It is the most volcanically active object in our solar system. And that's what makes it incredibly strange because, again, Io is the same size as our moon. And yeah, our moon had lava flows like billions of years ago, but it doesn't have any active volcanoes now, let alone hundreds of them. So how is it that this little moon is so very, very active. And it turns out that poor Io here is trapped in this tug of war between Jupiter and the other moons. So we have Jupiter on one side pulling Io towards it, and then we have the other moons around Jupiter on the other side pulling Io the other way. And so Io's getting tugged back and forth from all of these different objects, and that's causing the moon to kind of be stretched and then released and stretched and released. And as it does so, the rocks inside of Io rub against each other. And just like you rub your hands together on a cool day to warm them up, as those rocks rub back and forth, they start to heat up. And because there's so much tugging back and forth, it gets really, really hot inside of Io. And that heat has to escape somehow. And on Io, it escapes as volcanoes. And so that is why we have so many active volcanoes on Io. And in fact, it's all of those volcanoes that actually give it the really strange color. That yellow color you're seeing is sulfur. So if we want to be a little bit more accurate with our pizza moon description, this would be more like a rotten egg pizza, which I think, Eli, we can both agree on would not be good.
Yeah, probably not.
All right, so that is the little moon Io. Now, next up, the next moon out is the moon Europa, which is another very interesting moon of Jupiter, but for slightly different reasons. So Europa, if Io is the kind of a moon of volcanoes, Europa is the moon of ice. Because we can see here, the surface is covered in a thick layer of ice. Now we do see that there are cracks in the ice, kind of looks like maybe someone was ice skating, but those cracks are due to a similar kind of tug of war going on between Jupiter and the other moons. But since Europa is further away from Jupiter, that tug of war isn't as strong as what's affecting Io. And so it's enough to kind of warp it, to crack that crust a little, and to heat up the interior a little bit. But what's interesting is what else this might be causing. Because we have water ice on the surface, and it's hotter inside, that ice inside of the planet is probably melted, giving us a huge ocean of liquid water underneath this surface of ice. And we're not talking like tiny little ocean. Like I say huge for a reason. We suspect that there could be twice as much water here as we have in all of Earth's bodies of water combined. An absolutely gigantic ocean. And this super excites astronomers because one of the things we think is absolutely necessary for life to develop is the presence of liquid water. And so if we have a huge ocean, there is a chance that life could have developed here. And we could have little alien fishies swimming around underneath the icy surface of Europa. And so because of that, and because this is such a good candidate for somewhere else that life could be, we are actively working on a new mission to go to Europa, land on the surface, either melt or drill our way through that icy crust, and explore that ocean below. Now, this is a very complicated mission. There's a lot of factors to take into account. So we're probably, I would say, a good decade out from this even launching. But I'm super excited, and I hope that we can get there and get some results within my lifetime, because I would love to know if there's any life down there. All right, so the next up of Jupiter's Galilean moons is the moon Ganymede. And Ganymede is quite interesting and also in shadow, so let's just, oops, there we go. Ganymede is interesting because it is the largest moon in the solar system. It's actually bigger than the planet Mercury and about 3/4 the size of the planet Mars, so just giant moon. But other than that, it's not quite as interesting as Io or Europa because it is even further out from Jupiter. It does experience a little bit of that kind of back and forth tugging, but not a whole lot. And so we see a surface that shows not too much going on. We do see some interesting kind of like swaths of where it looks like the crust may have split apart and maybe some water flooded the surface and kind of smoothed it a little bit, kind of like we saw on the moon, but with liquid water instead of liquid rock. But based off of where all of this is and how many craters we see and how bright or how dull it is, we don't think this is actively going on. We think that this is something that happened earlier on in the history of the moon, a couple billion years ago. But it's still really cool just to think about how big this moon is. And then the last of the Galilean moons, the furthest out, is little Callisto, who unfortunately isn't as interesting at all as its three other sibling moons. We see a surface that's really just kind of dark in color, even though it is ice. This is a kind of dirty ice. We're seeing lots of rocky debris left behind on the surface from the things that have hit it over and over again. And so we see just this dark ice covered in craters. Not too interesting here, but still one of the kind of larger moons of Jupiter with little Callisto. All right. So those have been some of the moons of Jupiter. As I said, it does have quite a lot of others, but most of them are not that interesting, lumpy space potatoes. So we're not going to go see any more right now. Instead, we are going to head on to our next planet, which is Saturn. And as we fly into Saturn, we can see a lot of moons again. Saturn actually has more moons than Jupiter. It has 82 moons. Most of them lumpy space potatoes, although lumpy icy space potatoes. They're more like captured comets than captured asteroids, just because we're further out, further away from the asteroid belt, and more in the realm of like where icy comets and stuff fly by. But just like Jupiter, Saturn does have a few very interesting larger moons. And the first one that we're going to go see is Saturn's largest moon, which is the moon Titan. Now, Titan is the second largest moon in the solar system, behind Ganymede. It is also larger than the planet Mercury and about 3/4 the size of the planet Mars. But what makes Titan so interesting is it actually has a thick atmosphere. It is the only moon to have any sort of atmosphere at all. And its atmosphere is actually thicker than Earth's. It's about 1.5 times what Earth's atmosphere is. And as we can see here, that atmosphere is so thick that we actually can't see through it down to the ground. So it wasn't until the Cassini spacecraft got to Saturn. This is the spacecraft that spent many, many, many years orbiting around Saturn. Most of the gorgeous pictures of Saturn you see come from the Cassini spacecraft. But what Cassini had was a radar camera to peer through those clouds. It also had a little spacecraft called Huygens that it deployed that traveled through the atmosphere and landed on the surface of Titan. And when it did that, it showed us what lies beneath those clouds. And what we see is a very strange moon. We see these kind of dark markings across the surface. Some of these, and it's kind of hard to see in this image because it's not the highest of quality, but you can kind of see it right there, right in here, that some of these look almost like drainage networks, like dried up riverbeds flowing across the surface. Where Huygens landed, it looked like the rocks on the surface were kind of smoothed by flowing liquid, by erosion. No, I said rocks in quotes because we're very far from the sun. Those rocks are actually rock hard pieces of frozen water. The surface is ice. But what we found later, what Cassini ended up finding after the Huygens probe, we'll just say died, because very cold, was around the poles. You can see it really well here. There are actually lakes on Titan. Now, again, not liquid water lakes, because far too cold for water to be a liquid out here. It's rock hard as water ice. These are actually lakes of liquid methane. And this is very intriguing to us because so far, this means Titan is the only other world in our solar system to have liquid on its surface. I mean, not liquid water, but it's the only other place that we have found liquid on the surface. And that gets us thinking about, maybe some other type of life could develop here. I mean, just because the life we know depends on liquid water doesn't mean that's the only type of life that's possible. Perhaps there is a form of life that could survive these super cold temperatures and rely on liquid methane instead of liquid water. And so Titan is another place where we are really interested in searching for any sort of evidence of any type of life. We found, like, on the surface, there are amino acids, those building blocks to life, which means the pieces are there. It's just a matter of whether they actually came together and created life. And so we have another spacecraft that is in the works that is going to head to Titan. And it's actually a little quadcopter because there's a thick atmosphere. We can fly through that. And so this little copter is going to fly around Titan, which is going to let us explore a lot more of it before the cold temperatures get to it. And really let us kind of learn more about this very interesting moon that we have here. All right. Well, let's show some of Saturn's other moons a little bit of love, because Titan's not the only cool one there is. Another really great moon of Saturn is the moon Enceladus. So Enceladus is actually a lot like Jupiter's moon Europa. We have a moon that is covered in a layer of ice, and underneath that ice, we think there is an ocean of liquid water. But what's great about Enceladus is that's actually a little bit easier for us to possibly study this. Because towards the kind of South Pole, and you can't see it super well, but there are these cracks that are actually actively venting jets of water, water vapor, and water crystals from underneath the surface. So unlike on Europa, where we would have to drill through the ice to sample the ocean, with Enceladus, we could just fly through these jets and collect those stuff being spewed out by the jets, and that would let us learn about that ocean underneath. So it's another potential place that life could be, another great place for us to learn, although I know we're focusing a lot on Europa because Europa's ocean is bigger than Enceladus's. And so it seems more likely that we would find something there. But still, Enceladus is a cool little moon.
So we just got a question. I don't know if you were planning on wrapping up or if we want to wait for another couple minutes.
Oh, go ahead.
Are there any moons besides Earth's moon that has been explored by people or is able to be explored by people instead of equipment?
So we have not had anywhere else in the solar system that people have explored other than our moon. It's I'm trying to think. We could easily do Mars's moons, as we're going to Mars anyway, planning on that. The trouble with exploring something like the moons of Jupiter or Saturn with humans instead of just spacecraft is Jupiter and Saturn have really, really strong magnetic fields, and they hurl charged particles around very fast. And those charged particles could be very dangerous when they hit a human. And so, spacecraft, we can easily shield the electronics, but to send a human, we'd have to be a lot more careful with the shielding, and we probably wouldn't be able to actually walk on the surface, because I don't know that we have at this time any sort of spacesuits that could protect against the insane amount of fast-moving charged particles that exist around Jupiter and Saturn. So possible, maybe, but definitely not for a while. There's a lot that we would have to figure out before we could send someone to do that.
The other thing is that we get as we get further out into the solar system,